Hey everybody, welcome to Chapter 4. We're going to talk about the skin and body membranes in this chapter. We'll start with body membranes. I'll talk about the tissues that make up those membranes, where they're located, and what their major functions are, okay? And then we'll get into the integumentary system. So your first system, so yay. This is a beautiful picture here from my textbook that I teach anatomy and physiology out of from OpenStax, and it talks about all four body membranes here. So that's where this figure comes from. So we have four major body membranes. Three of them are considered epithelial membranes, so that would be your cutaneous membrane, your serous membrane, and your mucous membrane. And then we have the synovial membrane, which is a connective tissue membrane. Body membranes cover and line surfaces. They form protective sheets around different organs, and they basically keep organs from getting damaged easily. So the first membrane we'll talk about is your cutaneous membrane. This is your skin or your integument. It is the only dry membrane that we contain, or that we have. It's composed of two major regions, an epidermis, which is stratified squamous epithelium. It is keratinized, so it's very dry, but it's a very protective coating. And then we have an underlying dermis, which is composed of two different layers, a papillary region and a reticular region, that also provides protection. The next is your mucous membrane. So here's skin, here's the mucous membrane. The mucous membranes are moist membranes lined with different types of epithelium. So your mouth, your esophagus, or I should say your mouth and your pharynx are composed of stratified squamous, non-keratinized epithelium, so it's a moist membrane. Esophagus is stratified squamous epithelium as well. Then as you go into your intestines, that's a columnar epithelium. So there's a lot of different regions where the tissue type changes, but it's always going to have epithelium and then an underlying connective tissue. The major function of this one is, again, for protection, but it's a moist membrane, so it's going to produce mucus that will trap potential damaging agents, and then a lot of the membrane is going to have cilia associated with it that can move materials around to allow us to move those materials away from certain organs. Like in our bronchi, we have ciliated cells that beat the mucus towards the throat, so we can either spit or swallow that material. So here is your cutaneous membrane from your textbook. And then here is the mucous membrane showing going into through the mouth and the trachea, so pharynx to the trachea to the bronchi. And then here you can see it also moves into the esophagus. We have serous membranes. Serous membranes line, and this is from your textbook, this picture. So they line body cavities that are closed off to the external environment. So these are serous membranes that line things like your heart, your lungs, your abdominal pelvic organs. And they contain three basic regions. So the best way to show this is by using a water balloon, or they're saying air, but I think water balloons are easier. When you take and you compress a balloon, either filled with air or water, the outer layer of that balloon is going to be like the parietal layer of a serous membrane. It surrounds the body cavity itself. The inner layer of that same balloon is what lines the actual organ. So that would be the visceral layer. And then inside that water or air, depending, is going to be similar to the serous fluid that we contain. And so if you're trying to figure out how does a balloon mimic your serous membrane, blow up a balloon a little ways, or what I like to do is just fill it with a little bit of water, stick it on your hand, and then take your finger and then poke at your hand with that balloon there, and then move the balloon and poke at your hand without the balloon. The pressure on your palm is going to be greater without the balloon. So what serous membranes do is they decrease stress, pressure, friction on these organs. So we find serous membranes surrounding our heart. The serous membrane surrounding our heart is called the pericardium. The one surrounding our lungs is called the pleura. And the one surrounding organs in our abdominal cavity is called the peritoneum. The last organ or connective, or the last body membrane is a connective tissue membrane, and it is known as your synovial membrane. So synovial membrane is composed of connective tissue, and the synovial membrane is found in all of our joints that are movable, freely movable. And so this is a picture showing a synovial joint. Synovial joints produce, or synovial capsules produce synovial fluid, which not only protects the joint as it moves, but it also nourishes the cartilage that is at the ends of all of these joints. So synovial fluid has a lot of functions, and we'll talk more about those when we get into the skeletal system. So at this point in the lecture, you should be able to tell me the different body membranes. You should be able to tell me what organs are protected by those same body membranes, and where each of these membranes is located. Now we're going to get into the integumentary system. So the integumentary system consists of the major organ is the skin. That's the only major organ. It's one major organ. But then it has a lot of accessory organs, including sweat and oil glands, hair, nails. So we're going to talk about all of these different things in this chapter. And I just thought this picture was adorbs because the integumentary system oftentimes gets overlooked. It doesn't seem like it's that important of a system. A lot of people think, oh, it's just your skin. It's not like a real organ system because it's not internal. But it is your first organ system that anyone's going to see. And so it tells people a lot about who you are and how you're feeling. Specifically, think about if you're going into, and most of you are going into a medical field, the first thing you're going to see on your patients is how they look. So do they have a flushed face? Do they have a pale face? Do they look like they're feeling well? Do they look like they're feeling bad? Are they bleeding? These are things you can see right on the integument. That's why I kind of thought this picture was cute. Don't bother me, I'm having a bad hair day, you know, and we've all heard of bad hair days. Hold on a second, my dogs are going crazy. All right. All right, so let's look at some of the major functions of the integumentary system. So some of these functions, or the major functions of the integumentary system, can be seen in table 4.1 in your textbook, and I think that's on page 113. And so one of the major things the integumentary system does is it protects the body from mechanical damage. So our skin is held together. It has very, very strong keratinocytes that are held together via desmosomes. Our skin keeps underlying organs from damage. We have a lot of layers of skin, and so anytime our skin is bumped, we're not losing well, we're losing a little tissue, but only the dead tissue cells on the very top. It protects us from chemical damage too because it is a waterproof barrier. It is impermeable to most chemicals. It protects us from thermal damage or temperature, heat and cold. Our skin has melanocytes. Well, so first I'll say heat from UV radiation, which is right below it. We have melanocytes that give us an internal or a natural sunblock. And so those melanocytes protect us from ultraviolet radiation. From thermal damage, we have if our body gets too hot or if our body gets too cold, our skin is going to be used as an organ to either produce more heat or an organ to release that heat from. We have protection from microbes. Our skin itself is slightly acidic in nature. We have an acid mantle that keeps microbes from being able to replicate too effectively, but we also have a microbial flora or a microbial ecosystem in our skin and on our skin, and those microbes, the ones that live in us all the time, are going to outcompete those potential pathogens. And then we have, because of the keratin, we are protected from desiccation. So desiccation is dehydration or drying out. Oh, whoa. We also have, and I talked about the loss or gain of temperature, aids in excretion. So whenever we sweat, we not only release water, but we also release waste products such as urea to the external environment. And then the skin itself helps in producing vitamin D from cholesterol. So when UV radiation hits those keratinocytes, the living keratinocytes can then convert cholesterol into a precursor to vitamin D, which then is going to move into our liver and our kidneys to be formed into the actual active form of vitamin D called calcitriol. So I'm going to stop here because this has been 12 minutes, and we'll talk about the structure of the skin in our next video.